Hi everyone, so I'm Eric, I'm coming from Brazil with this guy as well. I am Microsoft MVP and Google Developer Expert. It's just names for who share acknowledgement and trying to do something. So we are from communities in Brazil, so I came from a poor city there and then we are growing a lot of communities of development. It's very nice. And this talk is about how serverless applications happens or what we have to avoid when you are working with serverless applications and some useful cases that I just suffered in the past. So to start, the first thing that we think when we saw the serverless is just, oh, let's burn my server. I don't need more servers. And then I will use without service. So it's very nice. But now, I think we have to think where we are now. So we are on the trending. So we have a lot of fancy words, like we have monoliths. So we have a big system with all the features inside the system. I have microservices. We have just split our responsibilities between across services, and these services could communicate with themselves. We have Docker, so Docker could help to isolate these microservices, and we need Kubernetes to use to handle the Docker and to manipulate Docker. So when we saw a lot of this work, the first thing that comes to mind is Jesus Christ, where you go? What I have to start? It's crazy because a lot of things, and all of these things is a new word to understand, and we don't know how to start sometimes. But actually, I will start more one fancy word. So I will start with serverless architecture. Serverless architecture is based on microservices. We have some similarities and some difference, but basically it's inside the microservices. We call as well a function as a service. So in this case, we have all of our infrastructure managed by a third party. So in this case, we are using AWS. But imagine we have a cell phone, a request comes to our API, so I have a service to route my services. When this call comes, I have to choose what is the function that will respond for this request. And now this function could be JavaScript, could be Java, could be any or a lot of languages. And this is actually our code running. So we have this service and all of them is services. In this case, I could use like a storage service, I could use a database, or I could make stream projects without a PC in the middle. So the key point here is we use all of services inside our infrastructure and we pay only what we use. So the first, I think, the cool and the bad thing is because we pay as we go. We'll see later why it's not so good pay as we go. But I think it's nice when we're starting and when we think we have a control on how many requests we have, or we have control of our developers, or we know what my company does. So yeah, it's really nice. And I think the context of service application is managed by a third platform. So we could use maybe AWS, you could use Amazon, you could use Azure. All of them, they have their own platform to handle these service applications. But we see some benefits and drawbacks of this approach as well. Yeah, but all of them will support you. Now we could use maybe JavaScript is the most popular. I think JavaScript will work in all of them. And I think one concept that I really like in all of this architecture is the event. So sometimes a trigger happens, and I have someone to respond. So in our case, on real case, we receive a request from our customer. We receive on URL, so like we need to create a customer. So this function, this route will send to my function that creates a customer and send to my database. I have other example. When I send a CSV project to a storage hub, when this event that a new file happens or a new file arrives, I could process in other function and save or manage in other things. So now it's always events running inside our application. I think it's very subjective. We saw a lot of compositions or explanations. For me, it was really hard. Okay, but now I can't understand. So for me, I think the good example is I have a file. This is a CSV file. It's a normal file with Aladdin there. So I have this CS3. So CS3 is just a storage hub. Could be any, could be a pen drive in that case. It's just our storage file, and we work with that. So our goal is when I have a new file in this storage hub, this file will trigger a function. So my JavaScript function, I have in this file just 10 items, and for each item or this whole system, I will convert to JSON, and then I will send to the queue. And the queue, we have all of these applications spared. So for each element that I have on this file will be one event, and for them I could process in parallel. So all of them could make a new instance of a function. So now I have 10 items and I can process 10 items in parallel. Talking about code, so it's just a JavaScript code, so much simple. So my principle is I have an event. This event will be a JSON with my data inside it. I want to get this data from the event. In this case, I'm getting just the name to know where is the data. And then I will convert this JSON from the CSV to JSON. And now I have my JSON array here. After that, I will send to the queue, and I will just finish my execution now. And now, when I saw that on my queue, I have a lot of items ready to be processed. And for each item, I have one instance of function, and all of them could insert in the same time on database. So this is a pattern. I think it's maybe one good example that you could use, but we have to be careful with some scenarios. But when I see that, oh, okay, now could be easier to understand that. That could be really easy, but okay, it's not so easy. We talk about the drawbacks and the real life. So the pay-as-you-go, I think this is a real scenario that happened with my customer. If something happens, you could pay more. If you see AWS, Google, you'll see, oh, I could have maybe 1 million requests, I will pay 25 cents, something like that. But you didn't see that if you have more processing time, you pay more. So, okay, in that case, we have my AWS account, but let's consider just the value. This is just 1 month of interns working in that. And we have my 1 million requests for free, but in that case, we have 80 billion seconds running. This was just a function that makes web scraping. That is a function that goes to a website to get data from the website and parse the PDF to a JSON and continue the process. But our problem was, when I send an item to the queue, I have to talk to AWS or to the queue. Oh, if you don't respond to me in these seconds, I will send more items to you try to process. This timeout, they set 0. So if I don't receive data from 0 seconds, I will send more. So I have the infinite loop running and a lot of instances running. We proved that scale. Yeah, but we have the surprise in the end of month. It was homologation or just development, and then we have this surprise. And I think one of the drawbacks is platform dependency. So imagine now Amazon just, oh, I don't want to make more system now. I just focus in AI or other thing. You have to change all of the things. I think we don't have words about it, but sometimes it's hard. Like to work on Azure, I have to learn maybe a lot of these services. If I go to AWS, I have a lot of these other services. And if I go to Google Cloud, I have other services. So it's the same idea, it's the same principle, but it's completely different. And sometimes when we come to AWS, we just see a new service that I've never seen before. So it's crazy. But it's not so bad. And maybe the lattice sometimes could be bad. When I saw like I have an external database in other place, and I have my services here or my APIs. To establish this connection, the network, the latency is bad compared to our traditional microservices or compared to my monolith applications. But this thing we could handle with other approach, but is something that you have to consider. And the cold start. The cold start is something, sometimes the people are making some workarounds to resolve it. So if you didn't receive a request, maybe in 24 hours or 10 hours, depending on the platform, the infrastructure just stopped to work, and then when you receive other requests, the infrastructure will be up again. But this up again costs some time. So imagine here I have the front end, and I received the request, and now here I have this article and the end of the slides as well. But we could see the latency or the speed of the request is very different depending on the time. So it's something to take care. And how do we solve that? Some people are creating some events. So this is from the article, is not me. It's just how they solve this problem. They have an event that they have a lambda that's ping all of the other functions to stay warm. So it's how they handle. This could solve the problem, but if you want to pay just per request, you have additional requests, and sometimes you have to create other routes to make that. So it could be sometimes hard. And I think decentralized architecture, sometimes it's good, sometimes I have the services and I could have a lot of developers working, but sometimes we could face like that. I have just a MapReduce application, and my services is just spread in my whole ecosystem. And if I have a new developer, it's really hard to teach them, and it's sometimes really hard to document it, all of that. And if I want an additional dependency on Linux, sometimes on AWS or Azure, I could have just the npm, just node.js, I will zip my code and I upload. If I want a new project, I just have to upload my binary. So using like Selenium WebDriver or Puppeteer to make this web scraping, we have to upload the binary there and execute on the Lambda. So it's a workaround, yeah. And then, okay, now we saw just a lot of drawbacks, but let's talk now about the benefits. So why we are here? I think technology agnostic. So we are so curious. We need to learn Go. We need to learn other languages. But sometimes our boss, if you put this on our monolith, or our team don't know how to create or how to maintain. But in this kind of architecture, I could have other different languages. So like in this case, I receive a request, I get the data, save on database. This save on database will trigger other event that could be Java handled. And this, after that, could be a C#, and then send an email. So could have a lot of different programming languages just to try or to make a proof of concept to handle that. And no worries about scale. Yeah, you saw how much I paid, so no worry about scale. It scales, but sometimes it's not so good to scale. Yeah, we have to take care about this. And independent deployment. So we have the small units. I could create independent versions. So I have a lot of services. Sometimes I have, I'm not sure about a feature. I could just make a canary test. I could test a new feature. I could test a new function. And then if it's not working, I could roll back and continue with no problem. And because that is easy to deploy an independent function, it's easy to test an independent function, but it's really hard to test the whole workflow. Is why we have asterisks here. So the people said, okay, now it's easier to test this. It's not so easy because you have the whole ecosystem that you have to think about it. And this is a good point now. Could be a benefit to be a decentralized, that is, we already saw on the microservices approach or concept. This could be really nice to spread our services and to scale independently our project. Okay, so let's talk about future. we saw we have some problems or benefits using serverless, but I think for me the big issue one that we have is I have to think that I have to install a new library, or maybe Node.js, only Node.js don't support my application. I need to upload a binary. But if I need to upload a binary, I have to version on my Git this binary. Sometimes the binary is 100 megabytes or maybe gigabytes. So maybe it's not so good, but someone are working in that. And we saw the last week on Google Cloud Next, the feature they released maybe 2 weeks ago, the Google Cloud Run. So I just tried today to see how it works, and it's really nice. So it's the ability to run our containers inside serverless concepts. So when I receive a request, they will up my container, they will process, and then my application could down. So I think it's not immediately down because we have the cold start and maybe it's a small time to process, but it could change everything. Now we are thinking, oh, maybe I have to use AWS because this and that search using this kind of application. I just think, oh, okay, I don't need a lot of services. I just will use my Docker file to use it. Okay, now containers, oh, change everything. We are thinking, oh, I have to learn each platform now. If it's Docker, it's a pattern, it's a standard for everyone. It's really nice. Okay, how do we start? I will just make a Git clone for my project that has already a Docker file and a project. In this case, I have just my Docker file. It's very simple Docker file. Just install a Node.js application. And I have just a simple Node.js application running inside it. It's not so different. And after that, I will build my image. So using Docker, we have to build our image. We have to create our package. It's like get the CD, and this CD is ready to play, but it's not played now. So in this case, I'm building the image, and the Google Cloud will upload to the Google Cloud. So in that case, we can't use like a public repository. You have to use the Google Cloud registry. So if you want to use like MongoDB, SQL Server, you have to maybe to build this image and use the command line and upload to Google. But I think it's because it's really, really recent, maybe. After build our image, we will just upload that. So after that, we generate an image. With this image, we could pass some environment variables. In my case, my database, that is other place. We have only the central US now, and I pass allow unauthenticated to everyone could access my application now. And now, maybe a few minutes, it's just so fast here, is making all the process, and now my application is online. They generate a URL for me. With this URL, I could just copy, and I could go to my browser. We could see that we have some time just working there to start my application, but my application is already on there. So it's very fast. This time that we saw is the cold start. Actually, this video has a speed, it's more faster than the common. But I think it's very good. I think it's a good start for us to use Docker to make our application. Okay, we saw a lot of concepts. Maybe it's a very boring concept, but I think this is the key points. So if you wanna go, or if you wanna enter in this world, if you follow these key points, could help you a lot. Just to not spend $1,000 a month just to try something. Yeah, I think the Docker could be really nice, but we have already some customers changing the whole infrastructure to serverless now because the cost is could be very cheaper just for APIs or API calls. They are using sometimes to make ETL process like extract, transform, load to make big data projects. But I personally don't recommend because you have to split your architecture in a lot of pieces and it could be hard. Okay, so Thank you so much, everyone. I'm so happy to be here. So glad to be here as well. Actually, I recommend you because we have actually a philosophy here. You know that the philosophy is nothing is for free. You have to learn, and you have to come back and teach each other. Yeah. Is this go? Yeah. So I challenge you to come here next month. Where will happen next month?
2 months.
In 2 months?
Yeah.
Okay, in 2 months. It's time to prepare yourselves. Yeah.
Come next month too.
Yeah, for sure. And to give a talk or give talk in other meetups. Okay? So here you could see all of these resources, the code sources here as well if you want. And thanks so much again.